Good morning, everyone. Namaste. I am Sonia Sachdeva Sharma, your coordinator for this session. A very warm welcome to the TSGSI Tech Deep Dive 2022 session on affordable ubiquitous access through heterogeneous networks. Before we begin, I would like to highlight a few hygiene instructions for ensuring a smooth running of this session. All attendees, except the session speakers, will be kept on mute, audio and video throughout the session by default. This conference is being recorded and will be posted to the conference website within the next few days. If you wish to view a previous session while the conference is on, please click on the watch replay button for that session. If you have any questions for the speakers, please type them in the Q&A tab. You may interact with fellow attendees live using the Chats tab during the session. If you want to enlarge your on screen presentation, please click the expanding arrow icon on the top right of the presenting screen. The tool is configured for HD. The attendees may switch to low definition mode in case you are facing any bandwidth problems. Attendees may like to visit the exhibit booth of TSGSI in between the sessions to know more about our work. Attendees can also use the lounge facility for networking. The lounge will remain open till the end of the conference. This session is co-chaired by Mr. Avinash Agarwal from Telecommunication Engineering Center and Mr. Anindya Saha from Sankhya Labs. I would now like to introduce the convener of the session, Major General Dr. Preetham Bishnoi. Major General Dr. Preetham Bishnoi, Vishesh Seva Medal, has 37 years of experience in provisioning of military communication in the Indian Army. He is associated with TSGSI as consultant technical since August 2021. He has been working in policy formulation in respect of cyberspace, communication, information systems, electronic warfare, and information warfare during his tenure in the military. Sir, over to you now.
Thank you, Sonia. Thank you very much. Firstly, good morning, everyone, all the panelists, delegates, and all the participants. I welcome everyone to the session on affordable, ubiquitous access through heterogeneous networks. I also would like to put it on record. I would like to thank you to Meta for the sponsorship of this session. This session is divided into two parts. Part 1, keynote, followed by Q&A session. Part 2, the panel discussions, which will be followed by question and answer sessions. I would now like to welcome to the co-chairs of this session, Mr. Avinash Agarwal from Telecommunication Engineering Center and Mr. Anindya Saha from Sankhya Labs. The brief bio of both the co-chairs are that Shri Avinash Agrawal is an ITS officer of the 1992 batch. He has 29 years of extensive experience in telecommunications, information technology, and broadcasting while serving in various positions in the Government of India. Presently, he is posted as Deputy Director General, Convergence and Broadcasting at Telecommunication Engineering Center, India's standard setting organization. Now coming to Mr. Anandya is a Chief Technical Officer at Sankhya Lab with approximately 26 years of experience. He is an expert on software defined radios and has led the design and development of the baseband and radio frequency subsystems for Sankhya's products in wireless communication. Now I invite Mr. Avinash Agrawal to make the opening remarks. Over to you, sir.
Thank you, Vishnuji. Good morning to all. I am expected to set the context for this session. as we are aware that the topic is affordable ubiquitous access through heterogeneous networks. So I will take out 5 keywords from the session topic and the conference topic. They perhaps define the session. So these 5 keywords could be ubiquitous access, heterogeneous networks, affordable, sustainable development, and 50 is standards. So if we consider all these 5 topics, basically this session is going to cover these important aspects, and we have a panel of experts. They would be going into the details. I will just give a brief overview. When we talk of ubiquitous, in general, it means ubiquitous means like omnipresent. So, ubiquitous access could be considered as always available, seamless coverage, or access to information which includes sending as well as receiving data anytime, from anywhere, or from any appliance using the best available network. So, like when we talk of ubiquitous access through heterogeneous ubiquitous access through heterogeneous network, we have a kind of context sensitivity available. It should be there that the network is being selected based on the situational and environmental parameters, and the best available network is available, and it is always connected. It should be zero touch, and the selection should be seamless. To elaborate this point with a few examples, so a very common example could be like if a person is outdoors in a city, he might be connected through a 4G or 5G network and using his mobile handset as a access device. When he moves indoors, maybe in his office or in his home, then perhaps the FTTH connection or the Wi-Fi through fiber would be providing better connectivity. It moves the connection moves to that uh, uh, access medium, and then the device might also be different, like they might be using a laptop or a fixed terminal. uh, but it is not just about humans moving or connectivity of humans. Now we are having machine to machine communication. Lots of connected devices would be there. So there will be connected cars. They will be moving from one place to another. They need to be connected all the time. Or if we consider that the person himself might be wearing lots of connected devices, maybe some life-saving devices, some pacemaker, some health monitoring device. Uh, so when we are moving from one place to another, when from one network to another, one environment to another, not only our mobile handset or our internet connectivity is required, but the connectivity of these devices is also required, and then it should be seamless. In certain cases, it cannot we cannot afford to have a discontinuity in the connectivity. So there are lots of issues, lots of challenges. Uh, if we think of another example from a broadcasting side, so maybe when we are outdoors, perhaps we are accessing some TV channel on the mobile handset and through maybe mobile data. When we move inside, perhaps the session must be available on our big screen fixed TV. There are different aspect things involved, like the screen size, the aspect ratio changes. Now if we further complicate this example and we add people with certain disabilities, if they are accessing the broadcasting content or the multimedia content, and they are viewing through captioning, reading what is being said through a caption, so it should also be seamlessly available like on the mobile handset. And then on the big screen, the positioning of the caption, the size of the font size, the background color, all those things need to be adjusted. So this is just one another example. uh, so there are challenges and there are technological developments happening. If we think of another keyword, which is sustainable development and affordable, so when we talk of universal access, it has to be affordable, because if it is not affordable, then a huge population would be left out. Similarly, when we talk of universal access, we cannot leave out people with disabilities, which we call PWD, or people with different abilities. We have to ensure that accessibility is available to all uh, uh, without any disability, without any not available to people with different kind of abilities. So there are lots of challenges. There are technical challenges which include seamless connectivity, context sensitivity, resource management, device management. But of course, technology will take care of these challenges. At the same time, there are other challenges which are kind of policy level issues also, uh, interconnectivity issues, revenue sharing, uh, access to data, security of data. So a lot of things are available. A lot of challenges are available. Uh, I will come to the last keyword, which is standards, and which is also the main job of TSDSI and also TEC. So when we are moving very fast at the technology front, if we do not move equally fast on the standards development front, then perhaps the technology would be there, but it might not get properly adopted. Because to address the challenges and to have a seamless connectivity and to address not just the technological challenges but also the various policy level and other challenges, we need standards. So it is time that we move very fast on the technology front also, and also equally fast on developing and adopting standards. uh, with this I would like to conclude for now. Thank you.
Thank you so much to Mr. Avinash Agrawal. Thank you, sir. Now we will start with the part one of our session, that is keynotes. So I would like to invite our keynote speaker one, Mr. Prashad Bhatt from Astrom Technologies, to speak. Mr. Prashad is a serial entrepreneur and technologist. Prior to Astrom, Mr. Prashad co-founded a successful company in the domain of visual search and artificial intelligence. He has been an architect for various technologies, including nanosatellites, a visual search engine at Streamoid, a stochastic game theory solver, the software tool for the latest 3D measurements, Texas Instruments chipsets. He has also published a book on stochastic theory with Springer Link. Over to you, sir, for your keynote address.
Hello.
So, should I share your presentation?
No, I will share my presentation.
Okay.
Very good morning to all of you, and thanks a lot, sir, for the introduction about myself and also setting the stage for this keynote. This keynote will be specifically focusing on the last mile related problems with certain viewpoint of the rural connectivity. This would touch upon basically the heterogeneity requirements in the network, as well as with the mindset of affordability. So I'll start off with the first action of understanding the rural connectivity challenges. When we talk about rural connectivity, we all understand that the penetration of the connectivity into the rural market is limited. But the first question comes, why? Why should that be lesser? The primary reason why the rural connectivity is limited is because of the geographical area. The rural area is practically tenfold compared to the urban area. So that poses a lot of challenge for an operator, because if you put, let's say, a telecom tower in urban area, you would easily address, say, hundreds of users. So that would generate that much revenue for one tower. Whereas the same kind of installation in a rural environment results in very few users. So your cost economics is a very important uh, thing to address, which is going to ultimately translate to penetration of the technology or the connectivity itself. So it's very important to understand that the rural connectivity requires better planning in terms of distribution as well as transport, and the solutions that needs to be adopted are not necessarily as a very standard, let's say, a simple process of whatever is followed in the urban market. So with that as a context, so I enter to the most important question as well. Why do we need to even solve the rural connectivity problem? Is it that critical? How does it really help? So that can be addressed in four different buckets. The first important aspect here is the population itself. If you see, let's say, the Indian system, there literally 63% of the population resides in rural areas. So that's a very really large market to address. The problem is the density of population is less, but still, nonetheless, 63% is a big market. Second thing is that we all understand that the economy grows much better if there is sufficient scheme, or rather opportunity to decentralize it and not like aggregate it to, say, specific cities, but be available in different rural areas also. So connectivity is one of the key means by which decentralization can happen. And the related matter of decentralization is that from a cost perspective, it is uh, perhaps much better for many factory to be set up in remote areas, because the economics works out better for them, in terms of setup, in terms of, say, potentially manpower, potentially all of the infrastructure related matters. Of course, the one of the infrastructure that needs to be available for that to happen is connectivity. And India being a strongly agrarian economy, agri-business, automations there, the IoT related sectors to penetrate to the agri-business, connectivity is again critical. So hence, I would put a point of view here that it is important to keep in mind that we need to have a very good solution for the rural connectivity from different domains. Now let's look at the overall scheme, or rather the landscape of how different technologies are present, and from two different dimensions. The first dimension is in the x-axis here, which is about the distance of coverage that a particular technology offers. And the other axis here, the y-axis, is about what is the capacity that a particular technology can deliver for that particular range, which is in X. What is the capacity that it can deliver? So I have tried to map different things here. The first thing that I would like you to focus on is basically the three different buckets here. There is a bucket which I put for access, which is like either 100 meters, maybe going up to a kilometer kind of range. And then you have this last mile, which is actually a misnomer, but we all have fallen in that trap of calling this last mile, which is of the order of about 20 kilometers. And beyond that comes the core transport in terms of connecting from one geography to another geography, the distance being limitless. So these three buckets, if you keep in mind, so core transport is a bucket which is addressed by predominantly fiber these days, and slowly the geo has been present, but its market share is extremely limited. Geo standing for geostationary orbits, MEO standing for medium Earth orbit satellites. So those have been slowly gaining some ground, but hardly less than a fraction of a percentage. So the new player in the market is basically LEO, such as constellations such as OneWeb and Starlink. These are entering here, which gives reasonable mid-size bandwidths, but at the same time, it is also slowly gaining a market presence in terms of percentage. Still very low, sub percent level market right now. This is one of the markets which will grow. So this is at the core transport level. If you look at again on the access side, there are a plethora of technologies. If you consider Wi-Fi, the recent the Wi-Fi 6, and there's a Wi-Fi 7 which is coming up. All of those are about addressing that about 100-meter kind of ranges or even lesser, but delivering to the end user at a very high capacity. And even in the 4G, 5G domain, you have these pico and femto cells which are coming up, which could cover just one building or one area, very tiny area of say 100 meters. Those are gaining ground in access. Of course, there is in a very standard setting, if it's a this infrastructure with a building, you would have obviously LAN cables lying around, which will give very high capacity. Nothing can read that so easily. But it still comes with its own limitations because you need to plug it in, you need to use it, all of that. It is still worth mentioning that we don't. Uh, it's worth keeping that in the view. Certain other aspects which I would like to touch upon here is the if you look at this last mile kind of bucket, you have certain things which have also crept in here, which is like the V band P2P device. V band is a band, specifically I'm focusing on for 60 gigahertz, is a band which has limited range, but it still brings in very high capacity for that limited range. So that's still worth mentioning. It's not technically access, but it is like semi access kind of bucket there. And of course, the 4G and 5G base stations which are coming up, they are, or rather the 5G in particular, is basically the coming close to this high bandwidth bucket and in the sub kilometer or a kilometer kind of range. Now let's fully focus on the last mile technologies. You have a whole gamut of technologies from the spectrum of low bandwidth to the high bandwidth. I will go through these technologies one by one. That is coming up in the next slide, so that we focus on the positives and the negatives of each of them, and how each one is useful in some way or the other. Um, first, talking about the optical fiber cable, this is literally there in every network that we can conceive right now. And I have put one small marker here just to remind us where does this fall. So this is essentially falling in the very large distance to say the last mile, and giving very high capacity. So if you look at this, basically its positives are high capacity, and it can give you basically very what should I say, baseline to. It's a very well established process and a technology, and there is no question of spectrum issues which otherwise troubles the wireless related technologies, and really long range. However, it comes with its own bucket of problems, which is a reason for other technologies to come forth as well. It has very high capex, and its right of way is a very tricky problem, and quite often that derails the whole deployment and requires a lot more which I say capital, and its installation time is not small, unlike wireless devices. and its maintenance, especially for last mile, not for the core network so much, but for the last mile, it becomes very tricky because the last mile laying of the cable is not going to be very structured despite all the things. And in countries like India, we see digging of roads, digging of various things, and the cable getting cut. So the SLA gets affected significantly when because of these matters. So moving ahead, if you look at one of the important wireless technology, which is FSO, free space optics, it's an interesting technology which uses infrared frequencies and establishes a line of sight link. Now this gives you very, very high capacity. In fact, it can go to 10, 20 Gbps very easily, primarily because the spectrum or the bandwidth that you get at these frequencies is very, very large. It spans in literally several gigahertz on a very, very easy node. And the capacity hence is very high. Right of way is quite simple. It's just a line of sight, and it doesn't really interfere. If you, even if you deploy multiple such devices in a geography, it doesn't interfere with each other. uh, and spectrum issues is not there. It's practically light communication. However, it is very bad in terms of maintenance, and also when you go to higher distances, it's a trouble. It is also troubled by basically fog and any kind of urban in urban areas. We also see this kind of particulate matters which sort of um, create an haze. So all of those affect FSO communication significantly. And there is one other tricky matter here. The beam width is very, very narrow. Hence, the pointing has to be very, very accurate. Or they need basically a good mechanical setup to align it and keep it aligned all the time. All of these actually limit the kind of adoption of this technology. So just to put the bucket, this comes here. It is last mile, but not very large range as it stands right now in terms of practical deployments, but very high bandwidth. Moving ahead, you have the other bucket, which is fixed wireless. This is a very interesting thing where you extend based on what is already established. So you have the LTE bands, you have the Wi-Fi 2.4 and 5 gigahertz bands. So you just increase basically the gain of the antenna, make it more directional, and put two of them and try to establish a link. So this gives you reasonably long range, but it is troubled with two, three factors. One is that the capacity that you get will be limited, not just because that the bandwidth is limited, but primarily because these bands are already used by everybody literally in every phones everywhere you have these spectrum being used. So what would happen is that the interference coming from other sources trouble this particular system a lot. So this basically is good when you want, let's say, uh, very low range or a very low capacity at a larger distance. So this technology is still having relevance there. The other one which actually gathered a lot of interest in, I would say, about 3-4 years ago, but I think the interest died down because of spectrum issues, is the TV white space. So this one is basically reusing the TV spectrum because that got speed up for various other reasons. And this can really give you long range communication. But the bandwidth is still less. So this is also falling in the same bucket of low bandwidth and reasonably good distance, large distance. The other one, which is very what should I say, proliferated in the market, is the microwave radios. You'll find these round dishes literally in every tower wherever you go in all places. So that one has a relatively long range, going up to 10 kilometers is feasible. The cost is very, very low, but this has spectrum licensing related catch points which troubles in terms of mass adoption. Even though it is used till about for 3G and going up to part 4G also, this is effectively good enough. But when you go to 5G and above, this is not enough in terms of capacity. So this falls again in the basically this low to medium. I should actually just correcting it here. So this comes in the medium bandwidth and good distance basically for last mile in bucket. So going further, the other one, as I mentioned earlier, the V band 60 gigahertz P2P radios. This one is available in the market, but it has extremely short range. So this is basically going up to only 200 meters kind of range because of oxygen absorption. But it can give you a very large bandwidth within that span. So going further, we have the E-band radios. E-band is a band of very high interest because this gives you very low absorption related problems, unlike the 60 gigahertz bands, and it can give you good SLAs and go up to easily 10 to 10 kilometers for sure, and going up to 20 kilometers. And it still has a relatively high capex. It's a high bandwidth solution for last mile, and basically the P2P radio particularly is all mechanically aligned. So there is certain constraint in terms of how you manage, and in case of misalignments, how do you correct it back. So there is some amount of disadvantage in that, and of course this requires line of sight. Line of sight for is more or less a requirement when you go to these higher frequencies, whether it is E band, V band, or FSO, or for that matter, even microwave radios have a certain expectation of line of sight, even though there is some you can do some play around there. Okay, now I'll just quickly touch upon the other two buckets, which was basically GEO, MEO satellites, and also LEO in the next slide. The GEO MEO satellites have their and they are all completely operational as well. It gives you tremendously high reach. Literally, you can install a dish anywhere in the span of let's say with one GEO satellite, you can cover one third of the globe. Uh, that's a very high reach, but it comes with extremely low capacity. The capacity comes down to trickling speeds of kilobits per second, which was okay perhaps 30 years ago, and it's like best case scenario with very big uh, high gain antennas. You would perhaps go to maybe touching an Mbps or maybe even up to 10 Mbps. That's about it. But at the end, it starts limiting in terms of overall performance and the applications that you can realize. Also, this has higher SLA issues in terms of, especially when you want to work with a reasonably compact terminal. And the cost associated with this service, because the capacity, let's say, that is available is limited, also shoots up. So, and additionally, the latency is really bad. It's not going to work for anything other than browsing. So, audio video calls will feel almost like the olden day trunk calls, if you're aware of that. So the capacity per satellite is the limiting factor here, and also the distance. In case of GEO, the distance is of the order of 36,000 kilometers, and in case of MEO, the distance can be anywhere between 10,000 to 20,000 kilometers. All of these essentially translate to latency. So that is a trouble in terms of scaling to the next generation requirements, even in 5G for that matter, and 5G and 6G onwards, it's very troublesome. Going further to Leo, Leo is the new market which is rapidly picking up. This put itself in the medium bandwidth bucket. See that here by marking it across, I'm indicating that this works for as a last mile and a core network, as well as it can work as an access. So basically, this has very high reach, just like Geo, and it has reasonable capacity. It has low latency. However, the SLA is still a question in the current technologies that are being used, and most of them are deploying in KU band, slowly looking at KA band, and with the future of potentially QVW bands. The cost associated here is significant. Because one satellite being closer, it's like these will be of the order of 1,000 kilometers or less. For example, Starlink, it is somewhere around 500 kilometers, and then If you look at OneWeb, it's around 800 kilometers. So the footprint per satellite is very limited. So you need large number of satellites. So that translates to cost ultimately. So and that gets percolated down to the consumers as well, the cost. So the the cost is an important thing. The second factor is that even though compared to Geo MEO, the number of satellites is high, hence the capacity is higher than that. It is still far lesser than, let's say, how much you would get by laying fibers. For example, the global internet capacity right now spans to somewhere around, I think, 700 TBPS or something like that. And with the SATCOM network of, say, the Starlink with 4,000 satellites, you would perhaps touch around 1 TBPS. So, which is like a factor of 1:700. So, that is still with that much advancement, still you will reach only there. So, it's going to capture a fraction of the market. So, that's another factor to keep in mind. It will still address some market. The latency will be definitely good, so that's a positive here. SLAs will be still of the order of 98-99% because rain fade and all of those matters are to be expected here. So this is sort of giving a complete coverage of various technologies. I'll just quickly touch upon one product that we designed at Astrom. So Astrom came up with this multiple point-to-point radio where we are essentially doing point-to-point, but multiple of them from one device. So we are basically doing this with an electronic alignment. So the antenna is smart antenna here. So that brings in basically certain disadvantages that are there in the E-band P2P radio and convert them into advantages, which is the capex per link comes down because multiple links are being found with one radio. And the OPEX is also lesser because the links are automatically aligned electronically. So even if there is a physical misalignment because of whatever reason, the system can correct itself. And the long range, all of those benefits stand as is. However, line of sight is still a requirement. This is more of a band requirement, E-band. That it can be addressed by multiple hubs, so that remains as is. So this is one product that we did, and of course this is a summary of various things that we did. I will quickly skip over. I'll just talk about one case study that we did near Mysore, where we try to put together different technologies, where we with an objective of 3 GPs to be covered. So we looked at OFC deployment, where we try to connect to all the villages from that gram panchayat, the 3 gram panchayats. Basically, those are 3 fiber pop points. From there, we were trying to draw out. So this is OFC, this is FSO, this is fixed wireless, and this one is basically existing E-band radios. And then we also looked at how gigamesh can address this. So when we put together all of that, we saw that basically the capex uh, per link, capex per Mbps, capex per Mbps per square kilometer metrics look somewhat like this. Fiber is a trouble in terms of total capex, followed by FSO, and most of the other technologies have reasonable budgets. However, when it comes to the cost per Mbps per link and cost per Mbps per square kilometer, ultimately we were seeing that gigamesh fares better, but others are in not very far off buckets. So that's the primary thing that we realized from all of this survey. We also did a recent deployment in one of the GPs, Sompura GP, and we presented this during the India Mobile Congress, where Minister Ashwini Vaishnaw actually interacted live with school kids there. So that way we started deploying this product as well for rural networks. So this is sort of a summary of everything that I had in mind. Thanks a lot for this opportunity to present to all of you. Uh, Thanks. Yeah, and perhaps we can look at questions.
Yes, sir. Especially, thank you very much for the detailed presentations you have made, sir, for the last mile connectivity. You have covered most of the technologies in addition to their advantage, disadvantage. So, I would request the audience any kind of questions, and Asif, please display those questions on the presentation.
Yes. So I think there was one specific question here. Yes, about long range Wi-Fi. So this is primarily the fixed wireless part that I had mentioned earlier. The line of sight um, is a trouble, yes, but it is not as much as a trouble for let's say millimeter wave E band V band. So line of sight is not a very strict requirement for long range Wi-Fi. But what troubles it more is primarily the interference. So when you let's say if you have a completely like a forest area and you want to do long range Wi-Fi, even if you don't have a very perfect line of sight, you'll still get a reasonable link. But the problem comes if there are interfering sources in the middle. Then that literally kills the link. Yeah,
Okay.
that was about that. Yes.
Yeah. Thank
What are
you.
the major issues related to the 470 to 584 and 582 to 700 TV white space? Yes. So the primary issue with TV white space is not the technology. It's more of a spectrum related regulations. That's one part, and also the capacity that it brings into table. I think the spectrum related issues. I mean, if not for those, I think it would have picked up and got some market share in India, but that is a trouble. However, technology-wise, please remember that this will be meant for low bandwidth.
Thank
Yes.
you, Mr. Prasad. Thank you very much for a detailed presentation, and thank you everyone. Now, because of the paucity of time, now I would like to invite our keynote speaker two, Sri Rajesh Gupta ji from USOF, Department of Telecommunication, to speak on ubiquitous access through USOF funded schemes, especially in the rural and the remote areas of the country. Sri Rajesh Gupta, presently posted as Joint Administrator, Technical and Administration, USOF, is an officer of Indian Telecommunication Service Group A 1991 batch. He is handling BharatNet project and is responsible for handling various issues related to the project such as evaluation of supplementary DPRs, detailed project reports, state-led model of BharatNet, O&M matters, operations and maintenance matters, coordination, social media outreach, Wi-Fi projects, and etc. So with this, we would request Sri Rajesh Gupta ji to give us the keynote address now. Thank you, sir. Over to you.
Asif, request if you can play the recording.
I'm very thankful to the organizers of fifth edition of Technical Deep Dive Conference of TSBI, held with the theme Standards for Sustainable Development. The session 4 of the conference is regarding affordable ubiquitous access through heterogeneous network. We are finding out newer and newer methods for services and solutions for the digital inclusion. When we talk about digital inclusion, the efforts of Universal Services Obligation Fund under Department of Telecommunication is very important, especially for bridging the digital divide between urban and rural India. With USOF2 coming up, we have started preparation for
covering all underserved areas in the country. The latest in this series is the new cabinet approval for ensuring 100% 4G footprint in the country by installing around 20,000 mobile towers, all in the uncovered areas. Let me first talk about our BharatNet program, which is aimed at connecting all the gram panchayats in the country to provide broadband infrastructure. This program is being completed in a phased manner, and under the BharatNet Phase 1 program, 1 lakh gram panchayats were made service ready by the end of year 2017. Subsequently, the remaining gram panchayats work have been taken up, and as on date, by laying around more than 6 lakh kilometers of optical fiber cable in the country, about 1.8 lakh gram panchayats have been made service ready. Let me just quickly show you the important outcomes of the BharatNet program. As you can see, 6 lakh kilometers of optical fiber cable has been laid under the BharatNet program. More than 1.81 lakh gram panchayats have been made service ready. This includes about 4,400 gram panchayats which have been made service ready on satellite media. These gram panchayats are situated in the most difficult areas of the country where optical fiber cable laying is very difficult. In the last mile connectivity also, about 1 lakh fiber to home connections have been provided in the rural area using the BharatNet program. Wi-Fi hotspots are also provided on the BharatNet Phase 1 gram panchayats. The dark fiber leasing is very important concept of the BharatNet, because with the 5G technology proliferating now, for the sufficient backhaul, it is very important that the optical fiber cable is utilized to its maximum to give the best effect of the required backhaul to the 5G technology. Especially in the rural area, BharatNet is likely to be utilized to a great extent. BharatNet program also actually have the equipment provided at the block level and the Gram Panchayat level, either in the GPON technology or in some states on MPLS. And minimum 100 Mbps bandwidth is available in the phase 1 GPs and 1 Gbps bandwidth in the phase 2 Gram Panchayats. And this bandwidth also is available for leasing to all the service providers on a non-discriminatory basis. If we talk about the major schemes of Universal Services Obligation Fund for the 4G connectivity, you can see on the screen the about say more than 10,000 mobile towers are under construction under various schemes of the Universal Services Obligation Fund. Under the LW2 program, about 2,500 mobile towers are under construction in the country in the deep Naxalite areas. Another program, namely Uncovered Villages schemes for the border villages of Jammu Kashmir, Ladakh, Himachal, UP, Bihar, Rajasthan. About say 354 uncovered villages are being targeted by installing around say 260 mobile towers. There the aspirational district program, one program under 502 uncovered villages, and the another program is 7287 aspirational district scheme for covering 7287 uncovered villages. These two programs are under implementation to cover all uncovered villages with 4G footprint. In the northeast area, there is a program running for Arunachal and 2 districts of Assam and another program in Meghalaya. Besides that, about say 1250 towers have been constructed in other northeast states like Assam, Meghalaya, Tripura, etc. In the island area program also, in Andaman and Nicobar, 124 sites are under construction for providing 4G footprint. The latest in addition is the 4G saturation scheme approved by Union Cabinet for 24,600 uncovered villages, which have been found with extensive exercise to find out the uncovered villages through the DOT field units information as well as from the state government. And around say 6,300 villages with only 2G and 3G coverage only, they are targeted to be covered with 4G saturation scheme approved by Union Cabinet very recently in the month of July end. With this completion of this scheme, which is targeted under within 500 days, all uncovered villages in the country are expected to have the 4G footprint, and the target is December 2023. DOT has also completed one program for laying submarine cable from Chennai to Andaman Nicobar, which will provide very strong backhaul media connectivity to the Andaman Islands. And another Lakshadweep Island also, submarine cable laying is under progress. and the target is May 2023. So with this glimpse of these various schemes which I just shown you, we want that a ubiquitous broadband coverage is available across the country, especially for the use of in the rural and remote areas of the country. With 5G technology, a number of new services, telefarming, telemedicine, telehealth, are going to be adopted in a large manner in the country. The new use cases on 5G technology are also being demonstrated for proliferation of this new technology in the rural areas. The telemedicine, the farming, telefarming, etc. are very important for low latency and low round trip delay to ensure the very live experience of robotic operations and many other applications which require real-time use cases. And the optical fiber cable laid across the country and being laid will be utilized fully for making this all possible. In addition to the 4G footprint being ensured in the rural areas and the optical fiber cable connectivity all across the gram panchayats and now villages also being targeted. The USF has also now made a telecom development fund in the country, and with the aim that 5% of the fund being collected by the annual subscription by the operators would be utilized for the hardware and software solutions, telecom solutions, use cases development, pilots in telecom sectors, specific product domains like 5G development, 6G and beyond technology level, IoT, machine to machine, and research scholarship, etc. And green energy efficient technologies for telecom sector. The technology or the R&D sponsorship program by the USOF is presently open till 15 November, and this opportunity may be utilized by all the startups, private companies, societies, research institutions, etc. for taking the advantage of the USO fund for various technology domains which I just mentioned. With all the efforts of the research institutions, academia, entrepreneurship, MSMEs, etc., I understand and I hope that we will have a ubiquitous network available across the country by the end of year 2023. Thank you and Jai Hind.
Thank you very much, sir. for your detailed presentations. If there are any questions, I will request Asif to flash them on the view file. And if there are none, then I will request Asif to flash these questions given of the previous speaker, Mr. Prasad, if there are any which has not been answered because of the paucity of time.
Thank you, Mr. Vishnoi, for the patient's help. And any questions related to yourself, you may forward it to me for our discussion and reply. Thank you so much.
Thank you, sir. We will forward those questions if there are any. So now we would begin the next part of our session, that is the panel discussions. I would request Asif to show the panel discussions, all the participants, all the panelists. The panel discussion will be starting from now, and the participants who will participate in the panel discussions, I will introduce all of them one by one. Ms. Charumati P is working as a group leader at CDOT. She holds Masters in Computer Applications from Punjab University, Chandigarh, and is certified project management professional. She has 22 years plus year of experience on design and development of IN networks, 2G and 2.5G networks, integration of 4G E Node B for femto and macro networks, design development and integration of Wi-Fi 5 and Wi-Fi 6 based access network and PM1 solutions. The next panelist is Mr. Jishnu, is a principal architect in CTO's office, Tejas Networks India Limited, where he is responsible for deciding the long-term roadmap of the company. He has been actively involved in the standardization activities at TSDSI from its inception, and at ITU radio and WP5D, 3GPP and 3GPP RAN 1 and SA2. The next panelist, Mr. Krishna Shirohi, is currently Professor of Practice at Bharati School of Telecommunication of IIT Delhi and is responsible for setting up new dimensions of academia industry collaboration for cutting edge research translations and the development of field worthy deployable products ahead of state of the art, aiming to meet emerging national requirements. Mr. Pradeep is having over 17 years of professional experience in the field of telecommunications. Currently, his efforts are also towards telecom standardization 5G and beyond 5G, oblique 6G in TSDSI, 3GPP, GSMA, etc. He has more than 35 granted patents in the field of wireless communications. In the past, he has also worked on many IoTs and IIoT projects alongside in the area of smart agriculture, smart city, including smart electricity meters, etc. Next in line is Dr. Pradipta Vishwas, is an associate professor at the Center for Product Design and Manufacturing and associate faculty at the Robert Bosch Center for Cyber Physical System of Indian Institute of Science. He has been elected as a vice chairman of ITU Study Group 9 and a co-chair of the IRG AVA and focus group on smart TV at International Telecommunication Union. Now, with this, we will start the session, and I will put through the questions as under. The first question to the panel is: the use of ubiquitous network is increasingly massively due to the speedy growth of wireless, broadband, and internet technologies. The question is: what are the most challenging aspects of ensuring affordable and all pervasive network connectivity in the entire India, resulting in reduction of rural urban digital divide? It is addressed to all, so we would request the panelists to throw some light on these questions one by one in the same sequence where we have introduced, if possible. Thank you so much. Over to the panelists.
So good morning, everyone. So, addressing this urban digital divide, like I at CDOT, we have been working on the PM Money network now for the last 1.5 years, wherein we have tried to democratize broadband by, like by having people like the end operators, PDOAs, who can provide Wi-Fi connections to the end users. So especially for the rural areas. So though it is both for rural and urban, but the highlight was to provide the Wi-Fi services in the rural areas. So one major challenge which has, curbed the proliferation of Wi-Fi in the rural areas is the lack of broadband, I would say, lack of backhaul. So one thing, like though, like even in the previous presentations, we have heard about so many technologies, so many middle mile technologies, last mile technologies. But on the ground, like when we are going, we are finding that we are not having the services, though there are so many attractive technologies available. But the proliferation at large scale is something that what we have to target, proliferation of the products at large scales, so that these technologies are made available at the cheaper cost. So through PM Vani, we have tried to empower that we have introduced new entities, so known as public data office aggregators, who can provide the Wi-Fi services, but they are facing the challenge of not having the fiber backhaul at every location to provide the services at reasonable cost. So that is one thing. So uh, we have to look, though the technologies are available, what I would say is that we have to see that how at mass scale we are having cost competitive technologies made, how the manufacturing can be take up in India, so that we are having the technologies available. We have to look at these aspects, unless like even like we have seen this E-band, V-band technologies, but are we having these technologies available at a mass scale with us, so that we can go about doing the deployments? Who are the manufacturers who are manufacturing this technology? So the manufacturing segment of the technologies have to be strengthened. Unless we strengthen the manufacturing segment of the technologies, we would not be able to bridge this urban rural divide. So we have to look at schemes, how the manufacturing segment of the technologies can be strengthened. That is what I would like to say from my side. Over to the other panelists.
Okay, thank you, ma'am. I would request to take on forward.
Hello. Thank you, Preetham. First of all, thank you. Good morning to all. Thank you for inviting me to the panel. So, just to add to what the earlier speaker mentioned, see, we have to understand that if it has to percolate deeper, the handset and the network has to be affordable. So, if you just look at Indian numbers, just for and compare it with the US, our ARPUs are around 145 rupees or 150 rupees, which is around $2, compared to $37 ARPU in USA. So that's a significant 16 times difference. The average handset price in India is around 20,000 rupees, which is like in US it's around 500. dollar is what the average selling price is. We have close to 115 crore subscribers and around 24 lakh base station. So on an average, we have 500 users per base station. But these numbers are in urban, it's quite larger, and in rural, it would be significantly lower in the sense number of users per base station. So if you have to make network affordable, you basically would have to sort out this issue of how do you ensure that, say, for example, 200 subscribers can use a base station and still it's viable. The second part of the issue which we have in India is like we still have 32 crore feature phone users, which is like users around, we speak around 25 minutes per day. So we still need, still have a substantial voice users. We have to ensure that voice also get preference. So the number of users, if you want to put it technically, the users per TTI has to be high. So all of this is sort of challenge in there. The second part, I think, even Rajesh sir was mentioning earlier, is how do you ensure coverage in difficult terrains, whether it's Northeast, Andaman Nicobar, or hilly areas. So it has to be funded by the government. So I see in the earlier presentation, Rajesh sir was mentioning that all the locations would be covered by 4G. Similar effort would have to be done on 5G also, because it is not viable commercially to deploy in many of the rural areas just because of this earlier constraint which I mentioned. The third thing is on indoor coverage in urban areas. So that's another issue which we have. So that it's not like urban area has sorted out all the issue. The fourth part is running. The operational cost is quite high. We still use DG quite a bit in our network. So it's not all, though we have grid connected, we still use DG. The customer acquisition cost, etc., has come down quite a bit, like with KYC, Aadhaar, and all that. But still, it's quite high. And then the other issue which usually happens is because of the how the licenses are given. The urban area gets the network first, and it will take close to 5 years for the rural area to get the network. So you can see that happening in 5G. The rollout of 5G has already started happening in cities, and like it has to basically it will take some time before it gets to rural areas. So how do you bridge this gap? All these 5 points would make it sort of ensure that the rural urban divide sort of comes down in future. Thank you, and I hand it over to the next man.
Thank you, sir. I would like to Professor Krishna Siroi.
Yeah, good morning. It's really pleasure to be with all of you today in this conference. The rural divide is the digital divide, or the have and have nots divide in the country is nothing new. Telecom has always tried to play its role to reduce it. Um, we have seen a major gaps in in accelerating the necessary level of programs for the propagation or proliferation of the technology in the rural areas so far. In spite many successful product development initiative of the past. If I take a couple of examples, the CDOT was established with this fact that the country will never have enough fund to buy the technology and maintain them within the country. If you need to go beyond the major cities, all the towns and the villages need to be covered. And that was one of the most successful program of the country in the telecom field so far. And it had created a business of 20,000 crore rupees between 97 to say 2003 2004, and 4 crore lines of network, which is 3 times more than what it was at the 1997, was established. We After that, we have somehow thought that the Indian companies are not in the position to meet the technological challenge which is needed in the field of mobility. And unfortunately, none of the Indian players has come forward with that demonstrated capability so that the indigenous solutions can actually be deployed. And unless until you have your control on the technology, you have a control on the manufacturing, you have control on the innovations, your research going ahead than the others, and you play a strong position and the role in a global standardization. All of them plays an important role, and a combination of them only can make us successful. So this is an area we have already made a beginning, particularly in the last few years. The policies are extremely good. There has been a huge initiative to support the indigenous manufacturers. Possibly they need to be given much more chance to prove their product into the field. Many of them have already been given this. This is a journey which has started, and I'm sure we will have a significant impact the few years down the line. I'll share more thoughts maybe in the next round. Thank you.
Thank you very much, sir. Now I would request Mr. Pradeep to share their views.
Um, Good morning, everybody. So I'd like to thank for this opportunity to present my views on this topic of ubiquitous network and affordability through heterogeneous networks. First of all, I would like to just make a generic comment here. I think all three terms here used in this topic, that ubiquitous or affordability and heterogeneous networks, I think they go very well hand in hand. The reason being, ubiquitous, like we're talking about coverage. That means like we are talking about scale. That means we are talking about the cost reduction, because the moment the scale comes in, your affordability increases in every aspects. And affordability means like we are talking about from an end user perspective, not just from the reduction in the prices for the different legs. But of course, it comes once we start reducing the costing and then the pricing at every chain, every link in the chain, right? Right from devices to the entire ecosystem. So I think they're all interlinked. So once the use cases leads to any use case that leads to scale, that brings in economy, and that brings in the reduction in the prices, that brings in affordability, and that can be achieved by heterogeneous networks, of course, because we cannot. I think one of the major thing when it comes to coverage, and also very much linked to this question of rural and urban divide, is we need to increase the coverage, and we need to increase the affordability, as everyone is speaking. And I don't think one of the other reason, other than people who spoke earlier in terms of make in India, manufacturing, control innovation, there are very valid points. Other points I would like to add is we also need to look at the deployments also in a different way. If we keep looking at as a specific technology itself will solve all the problems for us, then it might not help in solving the other problems in terms of coverage or affordability. So we need to look at a mix of solutions always, like if because the needs in the rural area, needs in the urban areas are different. In urban, the connection, the density and the affordability may not be a concern, but the density and the bandwidth requirements are very high. But whereas in the rural, the needs are of different. This thing where through your bandwidth requirements may be because of the coverage point of view, not maybe because of the higher throughput or a higher bandwidth requirements point of view. So we need to come up with a mix of solutions, and I think heterogeneous networks will definitely add. It can be terrestrial, non-terrestrial, and we need to come up with solutions and innovations in convergence of these mix of solutions. So this way we can definitely bring in, I think, because and also when we spoke about the digital divide between urban and rural, um, ultimately, if we talk about uh, digital divide or just the divide, it will be mostly because of the impact the solution or the technology is going to have on the quality of services of the lifetime. In the impact it'll have on the life of the people, right? So we need to work towards that, and look for the requirements, look for the use cases or the services that will have an impact. And definitely it will be coming under various segments. It can be the health, right? I mean, we need to give in better services in the health department in terms of uh, the roads, transport, So in all these cases, if a digital infrastructure can help, like for example, in earlier days, for every small thing, people had to travel miles and or kilometers of distance to get any services. Now, if that can be provided to them sitting at their place, right, that'll be a big improvement. So for few cases, like payments have become online now, right? UPI payments have come now. The innovations are coming up in terms of you don't need a smartphone, really a smartphone to do that. So affordability also comes, right? So if we can come up with smarter solutions than a smart devices itself to which increases the cost or the bill of materials for a phone to be manufactured. We need to look for other solutions which can be served along with the existing infrastructures also. So I think in this particular question, I would like to conclude with this, that like we need to look forward for smarter solutions. We need to look for a mix of solutions which can impact depending on the use cases for a rural and urban separately. Where rural, I will more look for a coverage, and urban, I look more from a density perspective. So, what works in the different areas, we need to deploy such solutions, and not exactly specifically look for one technology across rural and urban, and of course, with other points added earlier in terms of control on manufacturing and technology. Thank you.
Thank you so much, Mr. Pradeep. That's so grateful. Now I will request Dr. Pradeepta Vishwas to take on further from Mr. Pradeep. Over to Mr. Pradeepta Vishwas.
Good morning. Am I audible?
Yes, yes, sir. You are audible.
All right. Thank you. Thanks for the invitation. And it was a very interesting set of discussion, in particular the keynote addresses and also in the panel discussion. It looks like a very uh, very bright view for the future of India and also for the rural connectivity. And I'm really uh, feeling privileged to be part of this. I probably will talk on a slight different topic that Dr. Agrawal was briefly mentioning during his opening plenary. And as a background, that I am working with Dr. Agrawal and also with ITU for a while on promoting accessibility, and that means in somehow this connecting the unconnected, but in a different way, that people who cannot connect due to their different range of abilities. And of course, the effort is not alone. Like just last year, I was also in a discussion with IDBRT, who are looking at mobile banking for helping people, elderly people, or people with different range of abilities. And in this context, I think this is the best forum that where we can also at least discuss that how this connectivity can be also extended to people where people really need it. And it's not always that this small population, I mean, one issue with these people with disabilities is that many times they require customized solution, which is not very attractive for industry because they cannot scale up solution or the market size is too small. And that is a common point of avoiding improving inclusivities. Like for example, you may read about in just few days ago that Elon Musk, he fired the whole accessibility team in Twitter, and that is doing some round on social media. But here my concern is that when we are adding providing new technologies anyway, this whether this younger population, whether they are rural or urban, they are already growing up with all smartphone, Facebook, and all social media, etc. And although we have a lot of issues in terms of providing connectivity, but once we provide new applications, probably they will welcome it because they are growing up with it. But on the other hand, there is a whole bunch of middle-aged elderly population who were grown up with different technologies, and now we are providing all this e-banking and even the everyday facilities through Aadhaar cards, and we are asking them to do it online. And I think there is a lot of scope of improving not only the accessibility but also usability of the upcoming solution for this mobile for this elderly and middle-aged population, which will in turn be of much useful for the other part of the society as well. And there are plenty of use cases with that. And in this context, I will also briefly talk about some of our work in along with Dr. Agarwal, that we are Dr. Agarwal is now heading the question 11 on accessibility at study group 9 in ITU, and we are also working in collaboration with study group 16 who are looking at multimedia recommendation, and we are trying to develop a common user profile format which very optimistically or ambitiously aim to make audiovisual media content accessible to a wider range of population by defining appropriate metadata. And I wish and I am trying to run this development in parallel with this proliferation of 5G and proliferation of the transport and network layer of connectivity. So when so that both technology can converge at the same time, that when we indeed will have good connectivity in rural and otherwise unconnected region, that will be appropriately utilized by the intended population, and this language range of ability or age, that will not be a barrier in accessing all the new digital services. So yeah, that is a short addition or contribution from my side. And again, thanks for the invitation. Thanks.
Thank you very much, Dr. Pradeep Saviswas, for your detailed discussion on the topic. The next question, I will read it out. Also essential to meet one of the critical targets of the United Nations Sustainable Development Goals, a target for universal affordable access to the internet in developed countries by 2030. So, in view of the above statement of time, kindly highlight the technological innovation and key drivers enabling affordable, accessible, structured equity networks in the domain of wireless, wireline carriers, including satellite networks. This question also highlights the best manner in address the same, which will address all challenges. I will request Sarvamati ma'am to this question.
Am I audible? Because I'm facing some breaks in the voice. Am I audible?
You are audible. You are
Okay.
audible.
Okay. So, actually, with respect to the wireless technology, like currently, like I am working on the Wi-Fi technologies. So, with respect to Wi-Fi, I would be able to answer like the question that what you are discussing. So, like as we are seeing, like as the Wi-Fi technologies are, like progressing, the one need is the more and more need for the higher throughput and speed. So coming forward, like in Wi-Fi 7 also, basically it is offering a much more higher speeds. But with respect to ubiquitous, like expanded coverage or range right now in Wi-Fi, that aspect is not being worked out. It is more seen as a last mile access to the user, where more of throughput is being seen. But yes, definitely, one more thing is like we are also seeing that one technology will not be able to meet all the needs, so the technology has to coexist well with the other technologies as well. So in the Wi-Fi domain, whatever developments are happening in the physical layer, the work is happening so as to ensure that it is able to work well with the other networks as well, with the other technologies as well. So there are innovations happening in the physical layer in Wi-Fi 7, which also ensures that it is able to work well with a heterogeneous network. networks. So these are the innovations that are happening in the Wi-Fi domain. With respect to the other technologies, the other panelists can comment.
Thank you, ma'am. Over to Mr. Dishnu.
Yeah, thank you. So I think, on the Wi-Fi, as earlier speaker mentioned, Wi-Fi 6, 5, and 6E are coming up. So maybe we could even think of only a Wi-Fi only handset, in the sense, even the voice over Wi-Fi is slowly picking up in India, but it still needs a VoLTE control plane channel. So that is one thing. So the strange thing here is, like, India had deployed 6,100 railway stations are connected, I think, with something around 18,000 Wi-Fi access point. The consumption is 100 terabyte of data per month. So there is consumption even happening in rural areas, and I'm hoping it's quite a large deploy usage scenario even in rural railway stations, etc., which is happening. The second few technologies which are happening is, in the release 17 specifically, the bandwidth part, which was part of integral part of 5G, is allowing us to have an affordable handset. uh, the second part, which was about, can we have handset directly talking to satellite? So these are something which, uh, that's NTN based mobiles are sort of coming up. So maybe we can directly reach hard to place reaches, hard to reach locations directly on that phone. So these are from the technology from the handset side. Similarly, carrier aggregation, supplementary uplink. So these are something which India can potentially use, because we have been, uh, say for example, few operators have picked up frequencies in sub gigahertz band and higher in the sub 6 gigahertz band. So they can combine a different channel for downlink and a different channel for uplink. Even the technology which was developed by TSDSI, which is now part of the ITU standard and in release 17, which is 5GI, is another thing which could improve coverage. So that is another aspect of it. The few things which are coming up later, which is like, how do you offload your traffic, whether it's broadcast offload, or uh, whether if you can move some of your linear TV or live TV. You can see roughly in Hotstar, close to 1 crore people watch the IPL matches, or the right now the T20 matches. All of them are on unicast traffic. Can we offload them to some other thing, so that people could free up some of those capacity, which can again make the network affordable? The other thing is, like, if can we use AAML, which is another thing which is being discussed quite a bit in 5G Advanced, on basically load balancing, energy efficiency, etc. Sharing a network, MOC and MORAN, which didn't really pick up in India, could be something which can also work out for 5G. So that's something which I want to add to the earlier speaker. Over to you, Preetamji.
Thank you very much, Mr. Vishnu. I would request Professor Krishna Sri to take on from now onwards, sir.
Thank you, General. If you allow, can I share one slide for bringing my points?
Yes, sir. Yes, sir. Please.
Yeah,
Do you
just
want
give me a
us
minute.
to upload, or you would like to upload yourself, sir?
So, do you see my slide?
Yes, yes, sir. Yes, sir. It is visible.
Right. So, what I'm seeing is a great opportunity that the whole world now is talking about sustainable development goals, and these goals are very lightly synced with the Indian government policies. If you happen to know the details being done by Ministry of Panchayati Raj and the rural development, there are a lot of schemes which are being established, and I have personally seen at the various areas that a lot of development with these aspects are actually taking place. Now we are visualizing a gram panchayat as a revenue unit and taking care of all welfare functions of those villages. Going forward on this, uh, 6G and its association with the strategic development goal are very, very significant. And it also addressed that the first subtopic which you put forward for discussion, how this, the difference between rural and urban and haves and have nots be addressed, I'm very much optimistic about the way the 6G development strategies are evolving, where the goals are almost established. We are talking about not only the telecommunication, but we are talking about intelligence, we are talking about sensing, we are talking about compute, and all these things available everywhere. So certainly the villages are not excluded, and village I do see a lot of use cases where all these newer capabilities of 6G would be rather more utilized in the rural areas than the urban areas. And I'm really looking forward for new opportunities for India to play a significant role in this sector. It is quite clear now that the deployment scales are now something like we are global to regional to wide areas, and with 6G we are having a new perspective on local specialization and hyper local specializations. Now, what is this scale of deployment? So global is clear, regional is something like India, Europe, these are the regions. Wide areas, for me, it's a telecom circle. Now, these are the level of networks which are actually coming off the first category of deployment. This need to be very, global standards based driven. They will have the business running by the very well established MNOs, right? They are very strong system aspects, and they need to be interoperable. The roaming must be ensured. The economy of scale is so. These are the rules for the first three categories of the deployment scales ABC. But when we go further, the local specialization and hyper local specialization for me is a confined wide area where you have smart villages, is other campuses, maybe the smart cities. So these are the deployment for the local specialization. And when you go further for the hyper local specialization, these are typically a local area where one can visualize a rural critical care health center. It is not just phone or telephone and the video. It is a critical care where the ultra low latency of the network capabilities would be utilized. You also need AR/VR based education in the schools. You are looking for a tactical defense solutions based on these technologies, and you are looking for industry beyond 4.0. You are also looking for surveillance everywhere. These are the national requirements, and so this hyper local specialization and the local specializations are the areas where the solutions would be driven by innovations, and these innovations must come from the research outcome from these academic institutions. So far what we have been taking up an approach, a standards driven research. I think this is failing. This is putting a too much limitation on the research scope. It has to be a research driven innovative solutions which will be non-standard initially, but later they will become standards. At least they will become a national standard. We need not to really bother about whether they become a global standards or not become a global standards, as long as we have the entire ecosystem control within the country. Now, they out of this, some of them would certainly become a case for the global standardization, and hence these innovations should drive the pre-standardization activities within the country. And this standardization, pre-standardization activity can be driven in global phase only when we have the pilots results available with us. So this is the kind of thoughts I have for the major development. If I take a little more, one more minute, that the sequence goes like this, that you have enabling research coming out from the academic institutions, which are normally with a simulation based verification. You need to create a mechanism for experimentally verified research, which has been a bottleneck so far within our country. And the next stage of deployable POCs and the pilots, this aspect is completely missing in the country so far. So until we focus on these aspects, then only we become ready for the mass production, we become ready for the manufacturing, and then we have a substantial material to go to the global standards after carrying out these results with us. Just a paper-based presentation and making a pursuing in the global standards, I think we are weak. So this is the theme which we must pursue at the national level, and there has to be a kind of a bigger mission where more coordination between the academia, funding agencies, industry users, as well as manufacturing and operating companies. It has to be done in that fashion, and we should look forward for another 10 to 20 years by the time we get a significant impact of this, and the 25 years of the Amrit Kal must really be realized as a very developed nation. This is the proposal I want to have for people to further comment and adopt. Thank you.
Thank you very much, Professor Krishna Shiroi sir. Now I would request Mr. Pradeep to take on forward from here onward.
Hello, everybody. So I think the technology innovations definitely speaks for the ubiquitous network, right? So it covers both rural and urban. But not to forget again, the rural also has to be equally coverage has to be improved in the rural areas, as we spoke in the last previous question. Just one point add to it is because like what we saw some of the data points we get is like even today the rural economy is adding more than 50% of the towards the GDP and more than 60 to 70% towards the task force, the human task force. But the technology innovations that will help in these cases, of course, from the 3GPP point of view, if you speak, like there are a lot of work going on in the apart from Wi-Fi and BLE in the IEEE areas. So here's like Li-Fi is going on, NR Lite in release 17 onwards. RedCap, which is a reduced capability, that means the devices with a reduced complexity or a capability has to be designed. A lot of standardization efforts are going on there. A lot of things are happening on the NTN side, broadcast offload. A part of our TSDSA efforts are being worked upon. Then VTX, I think also from the quality of service and the deployment challenges, we can also look for slicings, wireless sensing, and other than that, like since the coverage, we spoke about the coverage in the rural areas and also affordability, how do we reduce the infrastructure cost in such deployments to improve the coverage? So one of the thoughts that is being also worked upon is part of the UAV, because the other supporting factor we have is the drones, localization, hyperlocalization, sensing. So many factors, if we can put together in, we can use drones as a moving base stations, which can do a lot of activities to the part of the coverage. Because in rural areas, like what happens is like for someone to build an infrastructure, an operator will be looking for a number of subscribers and the revenues generated towards from that. That will be the driving factors for someone to even look for improving a coverage in a specific area, which is like practical and is a need of the hour. But now in going now, since we are looking only all these days the human population as subscribers, right? So now with the IoT and the industrial IoT coming up, smart agriculture and many other applications coming up, the subscriber base is just of the human population. Now it will be a lot of other sensors and actuators and the devices which are developed, and that's how object to object or device to device kind of communications are coming up. A lot of work is happening on the D2D, and I think we cannot really ignore that because that is going to scale up heavily in the next few years. If some of the data from the Gartner and Nastasia, if we go by that, by 2030, there will be close to 28 or 29 billion of such devices. So that brings a huge scale, and that will help a lot of operators to start deploying because that is a coverage, right? So such devices and sensors and actuators once deployed will and it starts generating revenue. Then automatically the affordability increases and automatically the coverage increases because there will be solutions coming up there. And just to cover my previous point, UAV and moving base stations or the drones as a base stations will also help in such cases. Because, for example, if we take up a use case of an agriculture, today right now every farmer has to go, to particular farmland and what are the work has to be done. And if there are sensors put in there in the even the dairy farms or the agricultural lands and all, which can keep providing a lot of feedbacks. Because if you see today, smart agriculture, smart dairy farms has a lot of applications that can give lot of data to the farmers remotely, and they can do a lot of take care of a lot of actions. So if we need to do that, the data has to come back, right? So if we can't build an infrastructure, why don't we make a drone flyover which will just collect the data from the sensors from the land, because we know these sensors will not be transmitting the data all the time, so it will be like in a bursty data. That's a sole purpose in an IoT application. So the bursty data has to be synchronized. You send something, collect the data, they come back, and then feed to the rest of the infrastructure, and then the current infrastructure itself can take care of the processing of the data, or then me giving a meaningful report to the end user, like in case of a farmer or a dairy farmer. So we need to look towards such applications. I mean, usage of the technology towards such applications, and help improve the lifestyle and the services, because it has a double. Another advantage is like one such use cases and applications that's coming in, more and more people start using it, and then automatically scale increases, because I think we all know the economy is all uh, the cost can come down as the scale increases. So I think that's how we should target and improve the object to object or device to device communication also will be a key driving factors here. So that should be for now from my side.
Thank you very much, Mr. Pradeep. So nice of you. I would request Dr. Pradeepa Vishwas to take on forward from here onward.
Right. So I hope I am audible. So yeah, I am listening to it, and yeah, it's good that within this short time we already identified some gap in the present effort, and I believe that one thing I felt during both as an end user as well as a practitioner or researcher on accessibility, that still now many times all these e-governance service, the usability is not considered at from the beginning, or the when it has been sent to some tender or something, that where we are kind of engaging with the developers, that many of the time the developers, they are not aware of that how it will be used. And now these things have been taught in the primary any textbooks on usability evaluation or accessibility, but those are not communicated. So I think they are this is the start of the problem, that once we launch something, then of course it will come to a set of fixes which is never give the solution. And the second is that I do hear that now also during this lockdown time we have this work from home culture, and which again reignites the hope of all these immersive media, which were earlier only confined to these simulation training or very specialized industrial applications, but now they are proliferating into the education and edtech market, which is quite big in India. But also it is a bit risky endeavor that I think all of us, we are closely tracking this status of Byju's, and that is just one, and also that is just one of the examples. But of course, the edtech, it can work both way. And this introduction of 5G, of course, it creates new uh, opportunities of immersive education. Say, for example, some discussion we had here in helping medical students who are not in very high-end medical schools, that giving them access to digital cadavers to learn, where getting such thing is difficult. Similarly, for private engineering college, where people do not have all the equipments, that if immersive media becomes useful. And same thing for other specialized sector like electric vehicle making, solar panel maintenance, where which are all specialized domain, but where all these AR or VR training can be very useful. Of course, in STEM education also, it has plenty scope, and that can be possible now with the introduction of 5G. And in that context, I also want to merge our previous discussion, that there is a XR Access community, who also looks at the accessibility of extended reality and also the usability of the same. And I think there should be more effort. I mean, presently we are also working with the DOT on um, working on similar ambitious projects. And I do believe that in one hand we should be ambitious. We should not look at the Western world and wait for them to provide a solution, either Western or Southeast Asian, both we can say. We should have our own solution, but the other side, as the discussion is emphasizing on the rural connectivity, we should also look at the marginalized population who does not even does not have access to the existing technology also, whether they are in urban or rural sector. So I think we should take everyone on board. So yeah, that is a quick summary from my side, and thank you.
Thank you very much, Dr. Pradipta Biswas. Now, from here onward only, what I would request you, especially this question is especially to you only. Now, the persons with severe speech and motor impairment, you call them SSMI, belong to an isolated part of the disability spectrum. The complexity of their physical conditions renders them unable to have natural interactions with their environments, even for activities of daily living. So, in view of the above, could you share the details of an upcoming hackathon sponsored by India EU ICT collaboration that aims to help in the education and rehabilitation process of users with severe speech and motor impairment through teaching them use of cyber physical systems and associated eye gaze controlled human robot interface? Over to you, sir.
Thank you, General, for bringing that up. Yes, that is something very close to my heart, and I thank India EU ICT standardization collaboration for financing that. So we are working with this particular bunch of young adults and students, where this SSMI is umbrella term used to describe their condition, but in more common term that they have multiple disabilities. Multiple means that some of them, uh, most of them are quadriplegic, and in addition to that, they cannot speak, or many of them also have some difficulty in their cognitive abilities. Saying so, they are all attending this national open school standard, and still they are trying to uh, merge with the mainstream society in terms of education and rehabilitation. So what this in during this hackathon, we enable them to operate cyber physical system, and interestingly, they are already taking part in helping in the bakery or fabric printing processes in spite of their uh, range of abilities, and we are trying to help them in that process, and as well as in the education process by making things more playful. That means we are enabling them to operate toy cars and robots, and teaching them how to make use of them. In connection with that, we are organizing a workshop here on 28th and 29th of November in IISC, and colleagues are most welcome to attend the workshop. So within this week, I will also send a invitation to the TSDISI delegates. And there we will look at a much broader prospect of broader spectrum of range of abilities. So with the presence of some EU experts and colleagues from CDAC, we'll also look at the present gap in existing accessibility standards and the contribution of CDAC in Indian context. And professors from Europe, they will also present the situation in Europe, which is also a multilingual society like India, and what they are doing on XR technologies. In fact, we have another session next to it on XR technologies, and I hope some colleagues will be there as well. And just I would like to conclude one thing, that this SSMI, that is a very small segment of this the whole society. But just one interesting thing happened, that we started this work in 2019, and we make some prototype for them, prototype robotic system for them. And then 2020 we have the COVID pandemic, and those same prototype was extremely useful for our students who has to work from home, that they can took this prototype back home, and that lead to continue their research in robotics, which originally we developed for these kids, for these students with SSMI, but that was equally useful for their so-called able-bodied participants who has to work from home during this lockdown period. So that is just one example that what we do for people with disability that has a much broader set of applications. So thanks again, General Vishnoy, for bringing this up, and I cordially invite you to the next session as well as the workshop at IIS. Thank you.
Thank you very much, Dr. Prakash. The next question on the list: affordability of sustainability. Can panelists share examples of some of the successful Indian sustainable development of telecom products? This I would request all the panelists to throw some light on this, being a very important question. I would request Mrs. Charumati to commence, please. Over to you, ma'am.
Can you just repeat actually the
Okay, I
question?
will repeat, ma'am. Affordability is the key factor of sustainability. Can panelists share examples of some of the successful Indian sustainable development of telecom products?
Uh, yeah.
Your comments,
I
please.
think, like, if we are looking at sustainable development, so like that what deployed in like in the initial era of telecommunication revolution, racks and max, that only like we can talk as being a sustainable because it has held the test of time and it has been there in the networks for the like it has served in the networks for more than 30 years now. So and wherein we have even evolved the networks as per the technologies have evolved, so we have migrated our max networks from max to max next generation networks. So that like for me is like the biggest example for the sustainable networks. And yeah, to like a great extent whatever we have deployed as part of our 2G 3G technologies, also the multiple operators what they have deployed also has been sustainable. But the greater challenge with them is like as the technologies are evolving, basically we are seeing like from 4G now 5G is coming. So how much of the investment that has been done by the operators as part of the 4G networks, how much they are able to like make reuse of it, is something like which has to be seen. Because the key challenge, as has been brought up by many of the speakers like in India, is like we are targeting a very less like the revenues what we get are less, while we want to keep the costs as well like very competitive. So that is like the key challenge what happens in India, like we can't charge more from the user, while as the technologies progress, the cost, there is a greater cost involved. So with respect to the mobile networks, we really have to see that how much we would be really able to say that the technologies deployed have been sustainable. But definitely the landline network for me, that stands as the tallest example of being a sustainable network which has held the test of time and it has been able to serve the users. We can move to the next panelist.
Yes. I would request Mr. Jishnu to take on from here onward.
Thank you, Pritam. A nice question. So basically, what we have done to make the network sustainable is that we reuse most of it. In the sense, all our network are basically programmable. We call that ultra converged broadband. So the best example here is we started with SDH in something around 2004. We could reuse the whole hardware and migrate it to a complete packet network. So in the sense, only when you actually need to scale up your throughput or scale up your capacity, we needed to change the hardware. But otherwise, we could reprogram the hardware into basically operate it as a different things. Say from SDH, we went to MPLS. Similarly, what we are doing right now with our products are that we are converging all those into a same shelf, in the sense If you want to use it as pure transport network, we could use that same shelf as a transport network with some set of cards. But if you have to migrate it and work as a say LTE or 4G or 5G base station, all we need is add an additional card into the same system. So that's how we have been sort of making sure that all of these are sustainable. We are ensuring that we don't change hardware unless really needed. In the sense, if your throughput needs are much higher, we would have to change it, but otherwise we keep it quite sustainable. And this has been deployed in, say, whether it's in BharatNet or in Railtel network. All of this has been done in such a way that we could sort of provide them same hardware, complete different use cases, whether it is SCADA network in PGCL or a few of those networks. Same equipments are being used in completely different use cases. So that's one case from my side. Thank you.
Thank you, sir. I would request Krishna Shiroi, sir, if he can throw some light on this.
So, being in this field of developing telecom equipments and communication defense equipments in last 35 years, so the one example which I remember is possibly one of the best example in the country. In 2004, when we sat together and assessed why it is that you don't have the mobile telecommunication infrastructure available in the rural area, but you see a 100-watt bulb glowing. And so that gives us an idea that that time the base station power consumption was about 2 kilowatt. And we thought if it is possible to develop a base station, whatever capacity it is, a base station which does not consume more than 100 watt, I think this infrastructure becomes sustainable, at least from the energy consumption perspective. So this became a thought. We took about 6 months to decide what we should be developing and what should be the product definition and what should be the design objective and strategy to develop product of this nature. And this was one of the successful product. 2009 World Economic Forum gave this as the most innovative rural mobile communication product of the world. And this product is successfully working in BSNL network in a Naxalite affected area, what they call LWE, more than 2,000 base stations. And people don't hear any report in the media just because there is no problem in this network. It has been so successful. And what is the sustainability about it? It is not only the power consumption. It is this area which was the Naxalite affected area. The Naxalite of that area used to affect the operations of the mobile network whenever they wanted to do any major militant operation. And it was very easy to disturb the network operation, that they can cut the grid, power will not go to the base station site, they can block the road, so the diesel carrier will also not reach there, and after a few hours the network would be down. So this network, which was designed with this objective that you are grid free network, it was nicely engineered that your total power consumption was so less that a very minimum size of the solar panel was possible to keep this operation of this system with autonomy of 72 hours. So I'm sure there may be more examples, but this is one of the best example I have seen myself. And this product was possible to develop because somebody thought to develop it from the scratch and only pick up the right building blocks from wherever it was available, whether it is a building blocks in terms of a device or the protocol stack, or an expertise, whether it was lying in UK or Germany or Sweden or anywhere, but it was an Indian product. So my submission is that we should identify, and maybe the organization like TSDSI must publish that there are some good, sustainable, successful product examples within the country, so that they can be rightly presented to the large number of community who are deciding to work in a product development. And we are extremely looking forward for many more new success come down the line. Thank you.
Thank you, sir. So because of the paucity of time, now we will now take the questions from the audience for the panel discussions, because there are few questions in the chat tab. I will request Asif to flash them uh, so that the panelists can take on them. Uh, I would request Professor Roy to take on this question.
All right. So I don't see a question. This is a confirmation that what I'm saying is interesting, and there are initiatives in this direction.
Okay, okay, thank you, sir. Are there any questions in the chat, Asif? Sonia?
So the question is flashed. TSGSI conducts several workshops with regional entities, bilateral, through ITU ASP et al. These are leading to early discovery of candidates for standards. Should we categorize this as pre standards based innovations driven by local research?
So any of the panelists can take on this question, sir. And because of the paucity of time, we will take this as a last question. And after that, we will forward these questions to the panelists for them to answer.
So if I take it on this, what I was presenting in my slide, that research is much ahead in the stage, and research cannot follow the standards. It is rather reverse, that the research should be translated into innovative products, and innovative products must be piloted, and then only that input should be taken up for the pre-standardization if you really want to be effective in that forum. So this is the view. So my particular input to the TSDSI is that standards-driven research is actually not the theme. It has to be innovation. It is the innovation, research initiated innovation, and innovation driven standards must be the theme for the TSDSI.
Okay, thank you, sir. Any other panelist would like to say or comment on the question which has been flashed by the audience? Okay, then with this, I would thank all the panelists and the audience for the panel discussions and the question answer session. With this, I would invite Mr. Anindya Sir to make the concluding remarks for the session. So over to Mr. Anindya Sir for the concluding remarks. Over to you, sir.
Thank you, Bishnoy ji, and I would like to thank all the speakers and starting from the keynote. I think it has been a very insightful discussion. I think if I look at the keynotes, I think we started off with a lot of insight into what are the issues with last mile connectivity, the alternative technologies. Also, we got a good overview from Dr. Rajesh on the USOF initiatives. I think specifically what struck me was the kind of work which was being done, and also what is being planned. Typically, if you look at the connectivity, it is not only spanning the entire terrestrial, but also the islands, and the kind of different kind of mediums, whether it is VSAT, whether it is FTTH, everything is being used. So this was a good eye opener. I think more things are getting done, and that is something which we look forward for to USOF to do, and continuously. And I think the theme of ubiquitous connectivity has resonated very well with the strong set of panelists in today's discussion. And if you look at the viewpoints which came from everyone, I mean, one of the things I saw is that
yes, affordability is a must, for which the costs need to come down. We need to do make in India. Manufacturing in India is very, very key. Without that, it is not possible. I think that was one very strong theme which came out, and that we already see a lot of initiatives from this government in the direction. The other important thing I saw is the how to control the cost in terms of opex and all that, which is required. The also in terms of making it affordable. And when it comes to ubiquitous network, the other important theme, I mean, we heard about PM Wani, we heard about optical broadband, uh, and also leading to the directions which are going on in 6G, which is trying to make sustainability as one of the important themes. Sustainability through the use of sensing, intelligence, communication, and all that, and also intelligent use of AIML, which is kind of a catching buzzword today. So all these things have been highlighted very nicely by our panelists. They have been brought forth, very in a very cohesive way, and I would like to thank all of them. I think one of the other important things which struck me was the note from Pradeep regarding the fact that rural problems are a little bit different than urban problems. So it's not that getting to the the next G is always going to solve the problem. You need to look at it in a more holistic way, and maybe the solution lies in using a combination of solutions or combination of technologies. And the other important thing is, when you look at rural and connectivity, uh, one important thing which is there is, of course, coverage, but then what kind of services will enable them was very, very key. He also nicely brought in the fact that UAVs or drones could be a great enabler as we go forward, mainly because a lot of agriculture related work is going on. We are going towards smart agriculture and all that, and certainly the number of subscribers there may increase. I think the other important thing which struck me was the standardization possibility, which Dr. Sirohi brought about in his slides. I think, sir, we want to thank you for that. I think this is definitely something which TSDSI should take forward, and it's kind of good that we are discussing that in the forum today, where we should make use of whatever you mentioned a term called hyper local and local networks or even technologies, and taking them for pre standardization. I think a lot of interesting questions also came about in that direction. So that is one. And finally, I would like to thank Dr. Pradipta Viswas. I think he brought in a totally new dimension to what is ubiquitous network or ubiquitous accessibility. I think this is something which at least I had not thought of earlier, and this is definitely a lot of learning for me. And I think the work that Dr. Biswas is doing with the other stalwarts in ITU, I think that is definitely commendable. I think we should catch up with him for some other sessions. I think time today is constrained, but that also brought a very different dimension to looking at affordable and ubiquitous accessibility, which we usually don't consider. So I think overall it was a very engaging session. I think the last point about affordability being one of the key drivers of sustainability, and the insight from various speakers on their products was also very, very heartening to know. And I think specifically I like the fact about programmable networks, like Jishnu pointed out, how they help in reaching the sustainability goals. And then Dr. Charumati brought in the fact that the racks and wax are probably the most sustainable, because they have been continuing and they have stood the test of time. I think I kind of resonate that as well. And Dr. Siroi's input on how a kind of a power envelope was used as a constraint to design a network. I think that was also kind of, I would say, a very good example of how sustainable networks probably should be built and developed grounds up. And that also resonated with his earlier thought of local and hyper local specialization being used for designing networks. So I think overall it was a very engaging session. I think uh, I see 64 people are still in session, so I believe people were glued to it and were very delighted. I would like to thank the keynote speakers as well as all the panelists who have helped us shape this session. Also, would like to thank the TSDSI Secretariat folks as well as my co-chairs, and I would like to hand over the session to the convener, Mr. Preetham.
Thank you so much, sir, for your concluding remarks. We express heartfelt gratitude for the same. And now the best thing is that we have finished this on time, sir. The time was 12:45. So I must thank each and every one, both the co-chairs, all the keynote speakers, all the panelists. Thank you so much, and all the best. Take care. Thank you, sir.
Thanks, everyone, and it was nice meeting you all. Bye.
Thank you.
Thank you all.
Sir. Thank you, everyone.
Thank you, everyone.
Thank
Thank you.
you.
Thank you, everyone. Thank you.